welcome to my A assignment for our new BAM assignment project. The point of the A assignment was to find something in your house or around you that can rock or move in itself, and it shows periodic motion. What I chose was this latch from my ceiling fan. And what specifically this latch does, this latch once pulled sets the motors running and the ceiling fan goes into motion. But what more importantly we were supposed to do is find a way that we could put this, find its natural frequency, then find a way to interact with it at its natural frequency, and then see what happens if we dim away the natural frequency, or interact with it at a third or a half or 1/10 of its natural frequency. So in order to do this, we had to find the natural frequency of the object. And to find that, first we had to measure this. So I got my own ruler. I measured the length of this. It turned out to be 21 centimeters. Once we take conversion into effect, this becomes 0.21 meters. You plug that into your formula that was given to us, which says T, or period, equals 2 pi times the quantity of the square root of length over acceleration of gravity. Yes. Now once we plugged all that in, we got our period, which is just a measure of time, at 0.94 seconds. Close to 1 second, as in this will come back to you every 1 second, and then you can interact with it. But we want to know about frequency. So frequency is you use the time that you have for period. However, you use it as an inverse, which then means frequency is equal to 1 over your period. So once you plug that in, you get frequency equals 1.06 hertz. When your frequency equals 1.06 hertz, just use that as the inverse. So once, let's see if we could disregard this because it might block our perfect thing. So once we see this, and we set it in its pendulum form and periodic motion, and see if we can go back with every 1 second, or try to get to 0.94 seconds. This means that we are in oscillation with it, and which comes to resonance, which means that every 0.94 seconds, the end of what is acting as our pendulum is reaching back to my fingertips, which is able for me to be able to push it, and it comes back, and I push it, and it comes back, and I push it, and it comes back. So let's just hypothetically, I know that it won't work, but hypothetically, let's just try to see if we can get it in 0.94 seconds, which is an impossible measurement. So you push, and 1, 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 and 1. Thank you, Asia, who is my sister, for taking the video, who you probably heard in the background. So you saw that we were in resonance with it. We constantly matched the time it came back to us to the time it went away. Now, say we were to take that frequency and just do maybe like a third of it. So you see it's okay, instead of doing that 1, a third of the 1 would be like 0.33. So just say, okay, we're going to interact 0.33 of the time. 0.33 of the time. You can see I'm almost always missing it, because my hand and how I'm using the frequency of my hand is not in resonance with it. So it misses it, and maybe 1 in a million times it'll be able to touch it. But once we set that in motion, we see constantly my hand is trying to go at that 0.33 pace of what I think it should be, and it's not meeting up to it. But it was because either my hand is here, and then trying to push it, and then this thing is not set in a perfect, unobstructed free fall, because you see that the lamps are there and they're impeding on on the pathway, and it's not straight enough that the weight here is not straight enough that it will constantly want to go from here to here. But just to recap what we did, we found our frequency by finding our period first and then using the inverse formula to get our natural frequency. We found that the natural frequency was 1.06 hertz, which meant that in order for it to be easier, we interacted with it at 0.94 seconds. We tried to. Obviously, it was obstructed. Then we saw that, okay, when I'm with it, I'm in resonance, which means I'm constantly meeting up with the force being able to desire. And then we saw that if I just take away that time and start going faster by 0.33 seconds at a period of time, then it won't be in resonance. I'll maybe get it 1 in a million chances, but it will not be in resonance. And the goal is to be in resonance when the thing is in its our object is in its natural oscillation. Thank you very much for listening to my video, and hopefully I did well on this A assignment. Thank you.
Directed by me.